KBYP with more tinkering on the Drake. I've put a tremendous amount of time in this radio and a lot of money. Well over 3,000 hours total parts, including 10 of each tube except the 6 HS6. Well over $3,000. It was almost $850 just to get crystals for the sideband filter. But my goal is to perfect this radio without completely rebuilding it and be able to do this for others. I will not do that until I'm satisfied that it's right and I get good on-air reports from experienced operators, because they can hear a lot. I found proof that listening to a local receiver can be misleading. This rig was sold as being a sideband transceiver, one of the early ones in 1962 or 63. Worked okay on CW, worked okay on AM with a complaint of distortion if I turned the mic gain up too much. That's obvious. And very easy to fix. Turn the gain down. Just turn a knob. The more I worked on it, the worse the sideband got. I put in a bounce modulator circuit that was flawless. If you saw that video, as built and installed, there was a 1 millivolt difference across the bounce modulator transformer. That is perfection. New sideband filter, absolutely state-of-the-art crystals. Cannot get better crystals. Can't be done. They can't make them any better. Extremely careful work. Such good results with good crystals that the transmit power from this rig is almost twice what it is for most of these radios. I told them how much it was on a Drake group and they about fell out of their chairs with no explanation of how I did it. Well, so much for experts. But continuing on-air complaints of distortion in sideband, especially under bad band conditions with signals that are fading badly. And generally working operators running amplifiers, and I'm unamplified, and they're starting to lose my signal, and that proves what I'd seen before, that there's something wrong with the modulation peaks. And I had swept this transmitter till I was blue in the face, and I got a good envelope, except for some kind of odd distortion on sideband. The envelope would go up and then kind of dip and something, and I got rid of the clipping in the final amp. I knew it wasn't that, or I thought I did, but I didn't really know what it was. It shouldn't be doing that, and I didn't know what was causing it. Well, I got curious after last week getting another muffled report, and I says, that's it. There's only one rabbit hole I haven't gone down. And I didn't want to do it because I was going on the assumption that the radio is generally correctly designed by competent engineers and it should be okay. It should work. But the more I worked on this blasted thing, the less power it made on a good watt meter. And this is bad because it was making more power in CW. So I said, that's it. I'm not going to take anything for assumption. Nothing. Take nothing for granted. The only thing I haven't done in this rig is tear that microphone apart and tear the microphone amp into little bitty pieces. Actually, 2 amps. I had swept them and found a pass band of a few hundred cycles up to about 4 kc, and then it rolls off at 5 and goes down, which is way too high. Uselessly high, and worse, it causes excessive response in the sideband filter. A big complication of this is that sideband transmitters are a huge problem for amateur radio because most of us are male with lower pitched voices. And these transmitters are not designed to pass a few hundred cycles. They're generally 300, 400, or 500 cycles and above. With a very low pitched voice like mine, that tends to get very little power output from a transmitter without a lot of speech processing, which is why I get the best reports off that Kenwood. It has good speech processing. So I started at 0, took the microphone, measured the element, and that is a difficult thing to do. I measured this microphone, that astatic Drake desk mic. That's not a power mic, although it has a battery compartment. But that was made, turns out, for the Drake 7, not the TR3 and the 4. The TR3 and the 4 are for a crystal microphone element, and they have much lower voltage output. But I thought it was okay because I could turn the mic gain down to 9 or 10 o'clock and get a reasonably good report, but still not right. And when I listened in a local receiver, something just wasn't quite right. It had a little bit of edginess to it, a little fuzzy around the edges. It wasn't as clear as the Yaesu. Well, it's 60 years old. What do you want? Well, I want better than the Yaesu because the Drake is tubes, and tubes are much less distortion than IMD, which is a distortion product. So everything becomes suspect in every little detail. The Drake static mic, 1.95 k ohms, 20 to 30 Henry. Ew, I don't like that. That's a huge, huge inductance. Should be a low pass, right? High inductance, less reactance at low frequencies. Nope. My voice, I measured it on computer, about 70 to 600 cycles, real low. So I set up a test for the microphone, and that's a very difficult thing to do because where do you get a speaker that's perfectly flat? So what I did was use that arbitrary waveform generator to generate audio. That can be done with a PC. You can get routines to generate tones on a personal computer, put it through a pot and scale it down. And that's a very special speaker that has basically a filter-shaped pass band. It comes up at about 100 cycles and is very flat up to 3 kc. That's why I use it for radio. It's intended for a speech passband. Put the microphone right up near the speaker, about where it would be if I was using it, and increase the signal level from the generator into a audio amp into the speaker that gave a peak-to-peak voltage on the scope that was roughly what it was when I speak on the mic. So roughly the same level, as flat as I can get a test signal into a microphone. We sure can't whistle it. And then read the resulting frequency versus voltage for the microphone. And what I got was a flaming disaster. 200 cycles, nothing. 300 cycles, 16 millivolts. 400 cycles, 16 millivolts. Low to nothing. 500 cycles, 32 millivolts, 600 cycles, 78 millivolts. So here are the results. And for my voice, the microphone is basically only passing 500 to 600 cycles. Very, very, very important point. Hold on to that thought. Most of my voice is being cut out. There ain't much highs in my voice. I mean, you can hear it right now. I got a bullfrog voice, especially in the morning. 600 cycles, 78, 700 cycles, 85, 800 cycles, 85, 900, 81. So it's generally flat from 6 to 900 cycles. 1 kc, 60 cycles, and that's very important because that's the spacing in the original Drake TR3 and 4 between the carrier crystal and the beginning of the peak response in the sideband filter. So if anything's going to get through that filter at full power, it's got to be at a kc and above, and that cuts out most amateur radio operators' voices, which is why these TR3s and TR4s frankly sound like crap on the air. Low power output, can't hear them, a mid-range, pasty-sounding voice. 1K 60, 1350, 1544, 1936. So this microphone, even though it's 20 Henry, tremendous inductive reactance, its pass band is basically from 602 kc, which is just utterly useless. Which is why when I would talk into it, there was nothing indicated on the power meter. My voice was out of the passband of the microphone, never mind the mic amps. I didn't really know what they were doing. So that microphone is worse than useless. So I wanted to know what the response of the mic amps through to the final amplifier and out the back of the radio was at a frequency, steady state. There's no more basic measure than that. And what I found was an absolute train wreck that did not appear in a sweep. This is very, very subtle, and it fooled me. But the time I spent chasing distortion and thought it was clipping an amplifier wasn't. It was something hiding back here in the microphone and microphone amps. and I hadn't suspected it. There are feedback circuits in this radio. There's receive AGC to control signal levels, and the transmitter in the final amplifier. They sense grid current, and if the tubes draw grid current, then they fold back the transmitter by sending a negative voltage to the grid of the balanced modulator amp, which cuts off, basically reacts very, very fast and cuts off the drive to the finals. Because those television tubes, the 6JB6s, cannot take grid current. They will burn up fast. So they put a knee in it. So the drive level goes up too high. Boom, they cut off. Ooh, that's bad. That's not exactly saturation, but it's clipping. Makes a squared off waveform. That's what I saw in the previous testing of this transmitter. The peaks were squared off, and I thought it was amplifier going into saturation, but it wasn't. And I should have realized it because I knew about the grid limiting. So what was happening is that there's no low frequency response in either the mic or the transmitter. And in the transmitter, that's because there's no low frequency response in the sideband filter. In CW and AM, the carrier shifted 900 cycles in the stock radio to get into the passband of the filter to get the most power output available, and it never was full power because the crystals weren't any good. They were no good back in the day. The carrier is not shifted in the sideband, so there's almost 1,000 cycle gap between essentially no power output at carrier and full power output at 1,000 cycles up. That's completely missed my voice. So the microphone from the TR7 and the passband of the mic amp, the mic amps, have basically cut out almost all my voice, except for about 500 or 600 cycles. By using the generator and going at 100 cycle steps and turning up and down the amplitude, I found that what was happening is that when the amplitude from the generator was turned up to maybe 200 millivolts to get some response at 200 or 300 cycles, when it was swept up to 500, suddenly the transmitter clamps off. And that's exactly what I was seeing with what I thought was saturation before, and I should have known better. I made a mistake there, and it got me. But I didn't know what else it was. But there's the problem. There is no way for someone with a lower pitch voice, and that's most male operators, to ever get this transmitter to work correctly. It never worked right from the get-go. So that went against my theory that it was basically correctly designed in the first place. It wasn't, because it couldn't be, because the crystals were no good. So they were just stuck. The crystals are lossy, they're broadband. They got to move the carrier so far away that it cuts out the male voice. Good ladies rig, sure, but it didn't pass my voice much more than a few tens of watts on the meter, which is horrible because it should be roughly 300 input PEP, maybe roughly times maybe 0.65 efficiency for Class B, so it might ought to be 200 watts. And that's the goal I'm after. It's 180 now. It ought to be 200. So the problem is now I found another mic element. I went to the Chattanooga Ham Fest. I looked in the bottom of a box marked "Take it for free" or "It's going to the dump." And I found the prize of the Ham Fest. Old Motorola mic element, 50-83905, L as in Lima 01, which is 360 ohms and 3 millihenry, and has an ideal passband and a much lower output, kind of 10 to 20 millivolts. But its frequency response is down in the 100 to 500 range, right where my voice is. So that will be an ideal microphone element to take that one out and replace it. The microphone amp circuits in this radio are horribly screwed up because they were matched to the sideband filter. That filter's gone. There's a new filter. It's much better. So I can bring the carrier closer to the sideband filter and get my voice through it, which will make a tremendous improvement in sideband power output. Huge improvement. It will probably double the power output, maybe more. and they will notice it on the air, guaranteed. But what I'm doing right now is testing to reshape the audio response of the 2 microphone amp circuits. Not too hard, looking at the schematic, finding the capacitors to change, to at the same time increase the low frequency response and as much as possible cut out the response above the KC, because there's nothing in my voice above a KC, nothing worth having. And keeping the high frequencies out of the sideband filter really improves its passband, and I showed that in the filter testing video. If you'll notice, when the frequency was tightened down to about 2 kC, the filter shape improved. But the critical point was it was necessary to find the amplitude in, where adjusting the generator range across the usable voice spectrum from maybe 70 to 500 gives pretty close to full power output without the final stage being cut off, because that makes a lot of distortion. And that's a little tricky to do. It takes some experimentation, but hey, that's what ham radio is about, radio experimentation. The question is, I have no idea what they intended the correct microphone amplitude to be from the old crystal cartridge. High impedance, low output, and I have no idea what the frequency response was. Just so happens that they did tell me. And I found it by accident by simply taking the scope probe and going through different places and looking and seeing where this clipping was occurring as a result of too much mic drive. And oddly enough, it was occurring in the AM modulator tube, the 13DE7. At the plate of the first amplifier grid, the second, which are tied together, that envelope would flat top when the generator was set to about 72 millivolts. And that correlates precisely to a few millivolts with a level I determined by doing frequency step testing into the microphone amp circuits after I reshaped them. So fortunately, they did tell me that. I just had to go find it, and I didn't know it was there. So there are the specs for the mic input on this and the TR4, because the TR4 has the same mic amp circuit. So if you want to go looking for a better microphone, that's how to do it. So the improvement beyond that would be to use an equalizer or maybe a PC and be able to shape the audio in the way you want it. But it's still necessary to reshape the microphone amp circuit. You can't just do that with a stock microphone amp. It will not work, because you'll run into that severe clipping as the frequency goes up and the gain of the mic amps shoot up at 400 or 500 cycles, and the thing clips. So you will not be able to just put an equalizer in that mic jack and make it work. Okay, BYP.